Hey guys, Rao this side. Welcome to GATE Conqueror channel. After completion of this discussion, our conclusions will be like this. Inductance we are going to discuss, mutual inductance we are going to discuss, and this mutual inductance we are going to connect to our machines. And the second thing is kind of duality. Duality concepts we are going to develop because inductance capacitance they are dual. Okay, and also this is one more important interview question. You are going to get the clarity. Like in our spark plug will be there. No, spark plug will be there in our motorbikes, IC engines, petrol IC engines. Spark plug will be there. Across the spark plug, how much would be the voltage? Voltage will be very high in kilovolts. Okay, how they are going to generate kilovolts of voltage by using inductance, or how to generate huge currents. Actually, surge of currents can be created by capacitance. Surge of voltages can be created by inductance. How we are going to do that? We are going those are going to be our ultimate targets in this discussion. And before going any further, let me share about myself. I'm Rao, and I got 20 plus years of teaching experience, and I worked in more prominent institutes only. And the next thing is, obviously, I should have more than 1 lakh students, right? 20 years of life in this. Subjects, machines and network theory I'm planning, and I may include power systems also. And our this particular channel, Gate Conqueror channel, is meant for only English speaking. Okay, kind of all courses will be in English only because we cannot speak Hindi and all. Okay, this channel is meant for English speaking. Only English courses will be there because multiple members are asking me, sir, can you take in Hindi? No, I cannot take in Hindi, and my team also cannot take in Hindi. Okay, now if you want to purchase the course, use KNR10 such that I'll take more responsibility towards your preparation. And kindly like this session, share this session, subscribe to channel because it will give you kind of motivation to us. And next thing is in Unacademy there are two kinds of platforms: Plus platform and Iconic platform. In Plus platform you are going to get live classes, crash courses, weekly tests, and doubt solving sessions, and rank improvement batches. And courses will be in both English and Hindi. Means once you join any faculty, you can follow any faculty lectures. You can continue listening, okay, or understanding. Next is going to be Iconic. Whatever you are going to get in Plus, everything you are going to get in Iconic, and you are going to get one personal coach. That personal coach of your age will help you in reaching your target because already he's an achiever. And because multiple times we will get demotivation and all right during the preparation. And study plan will be given, personalized study plan, and study poster sessions will be there. Personalized test analysis will be there. This is actually very crucial because once our test is done, we have to do intricate analysis. Okay, that is better. And study materials also will be provided in Iconic subscription. And if you think of Plus subscription, if you use my code KNR10, you are going to get 10% discount. And also, whatever the code you use, you are going to get 10% discount, but you will become under my personal guidance. For 12 months, it is going to be 27,225 rupees. And for 18 months, it is going to be 34,650. And for 24 months, it is going to be 39,600. Now, if you think of Iconic, that is super set. In Iconic subscription, 40,500 if you use it for 1 year. If you want to take the subscription for 1 year, and for 2 years, it is going to be 54,000. Yeah, they thought of increasing the fee structure from July 1st, but they postponed that because of huge demand from the student community. At any point of time, they are going to increase the fee structure. So if you want to subscribe soon. And there are two kinds of batches. Lakshya batch will be there, Arohan batch will be there. Lakshya batch is meant for GATE ESE 2022 and Arohan batch is meant for GATE ESE 2023. All prominent faculties, because as of now, the best faculties of India are working with Unacademy, I can say. Most of them, like I worked with Ankit Goyal sir, Aditya Kanwal sir, Suresh sir, Vishal Soni, Bhim Shankar sir, Vishnu sir, Siddharth Subrawal, B.V. Reddy. There are all very prominent faculties. And here for EC also there will be two batches, Lakshya batch and Arohan batch. Lakshya batch is meant for GATE ESE 2022, Arohan batch is meant for 2023 GATE ESE. And again, faculties, awesome faculties. Test series, they are providing some free test series also, but obviously paid test series you are going to get more tests, right? So that is going to the test series. And here this is 4 crore plus scholarships combat. Every Sunday they are conducting combat, but this combat is going to be very big. And whoever get top 3, they are going to get free subscription. And remaining 4 to 10 are up to 100. Top 100 members are going to get some kind of scholarship, percentage of discount or something. And 500 lucky members are going to get iPads, iPhone, not iPhone, I think. This is Apple Watch, some kind of stuff. Yeah, if you want to follow me at KNRO for you in Unacademy App, such that whenever I come to take special classes or kind of plus classes, you will get the notification such that you can follow me properly. Okay? Then, mutual inductance. Now, first inductance should be started, right? Later, mutual inductance should be started. But I'm starting with mutual inductance now. Because with mutual inductance only, we can connect to inductance in a better way. Okay? Now, first of all, there are three guys. We have to know them in order to understand mutual inductance or in order to enter into machines. In machines also almost up to what they say 30% of this class will be continuum. Whenever I take machines directly with transformers. Okay. First of all, I'm not going to discuss about their life story, but whatever is important for us, whatever should be known by us, we are going to do that. Eichstätt found that whenever electrical current is there, around that some magnetic field will be there. Okay, and how it will be there? Nature. Okay, from nature we have, means if nature is providing something, we have to take that, and from that we have to develop whatever the systems we are going to develop. Okay, how current is creating magnetic field? Later, I'm going to discuss in detail. Okay, each and everything. Later, Ampere found that current magnitude and flux magnitude are directly related. Maybe you may think one thing, that whenever current is there, flux will come. And that magnitude of current and flux are directly related. If that is that much easier, directly related, so-called Eichstätt only would have found that. It is not that much easy. Okay? Yes, we are in network theory. And network theory is meant for linear, lumped, passive, something like that. Ultimately, it is linear. For linear, we can use this. But in machines, we should not use this. Okay? In machines, the difficulty of machines start with not valid. Okay? So, we can say that if and only if system is linear. Actually, we can call a system as linear in magnetic domain when relative permeability of the medium is constant. Okay, when relative permeability of the medium is constant. Relative permeability, hope you know. Permeability is constant. Then only it is possible. That's why, if you think of inductance in our machine, it is different because in our machine, around the iron we are going to keep the copper wires. But here in our network theory, means our copper or whatever may be the wire, we are not going to wind upon iron core, because the moment you use iron core, meaning that this will vanish. Okay, this is not going to be valid. Meaning that all of our mutual inductance, the difference between mutual inductance in network theory and mutual inductance in machines, which is nothing but transformer, is what? Iron. Okay, means if you are using iron, meaning that the story is completely different, because this is not going to be valid. And if you think of network theory mutual inductor, it is going to be air cored or non-magnetic material cored. So nothing will be there, just wire will be there. Inside, if you keep iron, situation will become different. Okay, because we cannot use this. I is directly proportional to pi, cannot be used. Anyway, means remember one thing, our mutual inductance in network theory or inductance in our network theory is air cored. We are not going to use high relative permeable material at all, because if you use high relative permeable material like iron, not valid. Okay. Now later, Faraday said that in any electrical conductor, I repeat, in any electrical conductor only, voltage can be induced if it is influenced by change of magnetic field, and that magnitude of voltage induced is directly related to rate of change of magnetic field. Okay, this we can call it as V or E, means EMF, electromotive force, or voltage, both are same. Okay, maybe we may see a bit of difference in machines. Okay, there like you are going to get a dynamically induced EMF, statically induced EMF, those many stories will be there. But for time being, voltage or EMF is same. Some voltage will be induced in any electrical medium. Conductor medium if it is influenced by change of magnetic field. Now, by using this, let us develop mutual inductance. Okay. At starting, you may think that we are taking, and with this session, actually till now, we used to consider only concepts, physics, some kind of stuff. But from after this discussion, or either at the end of this discussion, we are going to enter into whatever you feel network analysis, kind of waveforms, equations. And once a physical property is converted into equations, we are going to work on equations only. Okay, from very soon, we are going to convert our basic discussions, we are going to leave, and we are going to enter into the network analysis kind of equations, some kind of stuff. Okay, now let me take one conductor. This is electrical conductor, solid electrical conductor. Okay, and for this, let me connect a current source. That current source magnitude is I. Okay, it can be time variant or time invariant because I use small case letters, right? So for this conductor, let me connect a current source. Somewhere it is closed circuit. Okay, my focus is on this particular conductor only. Now, if you see, I should share that whenever you have electrical current, associated magnetic field should exist. Okay, what is magnetic field? Magnetic field is a curly field. Already we know. If I have NS pole like this, okay, so this is N, this is S. How my magnetic flux is going to travel? From N it will come out and S it will enter and inside S to N. Okay, so in this way my flux will be. Now my magnetic field always form closed paths. And one more thing is, maybe capacitance we connected with the physical reality because electric field. Okay, the moment our capacitance is mainly working with electric field is a divergent field like our gravitational field of the earth. That's why we managed some mass we have taken and ground floor, first floor, some kind of stuff. But here, the moment it is curly, okay, directly we have to understand. Okay, such a physically, like I cannot show anything. Okay, but anyway, magnetic field is a curly field, right? The moment electrical current is there, around that curly magnetic field should be formed. So curly magnetic field should be formed. It is going to form closed paths like this. Now, what is the second statement? Ampere. I is directly proportional to pi in network theory because network theory is meant for linear. I is directly proportional to pi. Now, let us take different current waveforms. Okay, if I take different current waveforms, this is I, this is time. Okay, now let me consider DC current, constant DC current. The moment you consider constant DC current, around that magnetic field also will become constant because I is directly proportional to pi. I is not varying, invariant with respect to time, automatically flux also. Okay, kind of if I have this as current carrying conductor, in this some current is flowing, around that magnetic field will be there, in a curly nature, or closed by its own. So many magnetic flux lines will be there. How many flux lines will be there will be decided by magnitude of current. Now, let me consider, actually this is my favorite waveform to understand network. Okay, in order to understand networks, I feel trapezoidal waveform is more than sufficient. Let me consider current. Okay, let me consider it as current, and this is time, and let me consider trapezoid current. Okay, and 0 to T1, my current is increasing, and T1 to T2, my current is constant, and T2 to T3, my current is reducing linearly towards 0. Let me consider this waveform. Now, again for this waveform, if I see the structure, see here, if in this particular conductor, if trapezoidal current is flowing, meaning that at T equal to 0, how much is the current? 0. So magnetic flux lines will be 0. And after that, my current is increasing linearly. So my magnetic flux also will increase linearly. Kind of, if you throw a stone on normal water, what will happen? Waves will be In the same way, means the moment current is increasing, my magnetic flux lines also at the center of this particular conductor, magnetic flux lines will be liberated. Again, magnetic flux lines, again, magnetic flux lines, such that these magnetic flux lines will be spreaded across this in this way. You understood, right? Now, if my current is increasing linearly, my magnetic flux also will increase linearly. And from T1 to T2, current is going to be constant through it. I is directly proportional to pi. So the moment current is constant here, automatically flux lines also will become stable, constant. Okay, they will not vary. Now T2 to T3, my current is reducing. The moment current is reducing, automatically my flux lines also has to be reduced. What will happen? See here, this particular flux line will slowly diminish and disappear at the center. Meaning that at the center, like whatever may be there nearer to the conductor, it will go first, and after the top one will go first. Everything is going to be diminished and disappear at the center of the conductor. At the center of the conductor by T3. Meaning that T2 to T3, my current is reducing linearly. So my flux lines also will slowly reduce and diminish to 0. Now, let us think of third one. What is third one? Some voltage can be induced if it is electrical conductor. Okay, in electrical insulator, obviously it will not come. Now, if it is an electrical conductor, if electrical conductor is influenced by change of magnetic field, automatically voltage will be induced. Okay, now, see here, let me consider I'll keep it here. Yeah, better. Okay. Now, if I consider one more conductor, only let me take conductor only at starting, one more conductor in the vicinity of first conductor. Okay. So basically, this is also conductor only like this only. And let me consider this as first conductor. Let me consider this as second conductor. Okay, and let me connect some galvanometer kind of stuff, one instrument, in order to know whether induced voltage is being induced in this particular conductor or not. Okay, now you are sitting on this particular conductor. Now, if you think of first waveform, okay, first waveform DC. With DC, what's happening means if I consider this as the first conductor where some current is flowing, and let me consider my finger as my second conductor where I am sitting upon. Okay, so this is electrical conductor to which our current source is connected. This is electrical conductor on which I am going to sit. Now, this particular conductor current is constant, meaning that magnetic flux lines are going to be stable and constant. They will not vary with respect to time. Then what is going to happen? If you sit on the second conductor, definitely you would feel magnetic field. But you don't feel change of magnetic field. You don't feel. Okay? Because some voltage can be induced. If it is influenced by change of magnetic field. So for DC current, if you think of this first conductor current as DC, you don't get any induced voltage in the second conductor. Because you are sitting here, this is constant current, magnetic flux lines are going to be constant like that only, so you don't get any induced voltage. So this particular instrument will not give you any deflection because induced voltage will not be there. And how much is the electrical, is there any electrical connection between first and second conductor? No, they are electrically completely isolated. But second conductor is in the vicinity of first conductor, that's it. Okay. Now, let us consider this waveform. Okay. So, what is happening here? 0 to T1, my current is increasing linearly. Again, first conductor. In this first conductor, my current is magnitude is increasing linearly. So, my flux magnitude also increase linearly. Now, this is the second conductor. You are sitting here. So, my first conductor current is increasing linearly. These are my flux lines. This is my first conductor. This is my second conductor upon which I am sitting without having any interconnection, electrical connection between first and second. These two are isolated. Okay. In my first conductor, current is increasing. So, my magnetic flux also will increase. While in increasing order, if you sit on this particular conductor, while increasing order, you are going to get induced voltage in the second conductor or not? Yes, because d pi by dt, variation of flux will be there. Okay. Now, see here, I'm increasing the conductor current here. Automatically, my flux magnitude will increase. In increasing order, it is going to link with the second conductor. So definitely 0 to T1, I can expect voltage. I can expect voltage. Okay. Now let us see T1 to T2. T1 to T2, again same situation, no? T1 to T2. T1 to T2, if you think of voltage, obviously there will be no voltage because it's kind of DC only. If you think of this as conductor current, which is constant, conductor current, which is constant, then automatically my magnetic flux lines also will be constant from T1 to T2. Then you are sitting here, you don't get any flux variation. Without any flux variation, you can't get any induced voltage. Okay. Now T2 to T3. T2 to T3, what is happening? T2 to T3, we can expect induced voltage. Why? T2 to T3, my current is reducing, meaning that my flux magnitude created by that conductor current is going to be reduced. Okay. If I think of this is conductor and these are flux lines. For example, T2 to T3, at T2, my current magnitude maximum, so flux is like this. Flux is like this. Now from T2 to T3, my current flowing through this is reducing, so my flux lines has to reduce because these flux lines has to disappear at the center of the conductor. So while reducing these flux lines, these flux lines are going to link with this conductor or not? Yes. Under that condition, in this particular conductor, can you expect voltage or not? Yes. We can expect voltage. Getting my point, right? So we can expect voltage here whenever you have current variation. So whenever you have current variation here, induced voltage you are going to get here. Without having any electrical connection also, some voltage can be induced if this particular conductor is nearer to this, okay, current source or whatever it may be, okay, current carrying conductor. Now, from here, machines means is going to be divided. Kind of, if you think of just like that, okay, if you think of how many flux lines are created, 1, 2, 3, 4. Out of 4 flux lines, how many flux lines are able to link to second conductor? 3. Remaining 1 flux line is unable to link. That is called as leakage. That term we will see. This is called as mutual, this is called as leakage. From there, machines will start. Anyway, this induced voltage, if you see, if I think of this voltage as 2, because this is second conductor. Okay. Now V2 is directly proportional to change of flux variation. Directly proportional to flux variation. This particular flux is created by first conductor. These flux lines are pi 1. Okay. So this is going to be d pi 1 by dt. Because of another flux variation, because of another conductor current variation, I am going to get induced voltage, that is, or we can say that, see here, I is directly proportional to pi, right? See here, I is directly proportional to pi, meaning that flux created by first conductor is directly proportional to current flowing through the first conductor. So this is going to be pi 1 is created by I1, so pi 1 and I1 should be related, because we are into linear systems. So this can be written as directly proportional to di1 by dt. Or we can say that V2 equal to m di1 by dt. This is mutual inductance. Okay, this is mutual inductance. This is, for example, if you think of our power systems. Okay, so in power systems, communication lines also will be there. And transmission lines also will be there. Okay, if I think of this is transmission line. And let me have communication line here. This is red is a communication line which is being carried on the same structure. Okay, then here black is going to have power frequencies. Okay, black is going to have power frequencies. Okay, why power frequencies range will be very less and all, it's a kind of different story. Power frequencies will vary all over the world between 40 Hz to 60 Hz. Okay, Communication, definitely in megahertz or gigahertz it is going to be. Frequency will be very high. Okay, kind of modulation, amplitude modulation, frequency modulation, some kind of much stuff will be there. But anyway, it is in megahertz or gigahertz. Okay, now whenever this current is there, okay, our communication current is there. Now because of communication current, induced voltages will be there in power line, and because of power line, induced voltage will be there here. Okay, but now one thing let me tell you, whatever may be there, and because of this particular currents, voltage will be there here. Because of this particular currents, voltage will be there here. Okay, now if you see communications, okay, in communications which is operating at least megahertz, for example, now in megahertz, if they add the frequencies of 40 to 60 hertz, nothing will happen to them. Nothing will happen to them because they can have high pass filter, and with the high pass filter they can do. But anyway, point here is very simple, means some voltage will be induced in this because of current here. Some voltage will be induced here because of current of this. That is nothing but mutual inductance. Okay. Now let us think of inductance. Okay. Now self-inductance. Basically, after mutual inductance, only self-inductance should be handled as per my view. Let us see. See, because of somebody else current, somebody else flux, if I get induced voltage, that is mutual. Because of my current, if I get induced voltage in myself, that is called self-inductance. Now, let us consider this as solid conductor, which is carrying some current. Let us think of again, this is current source, IL, because inductance, L, mutual inductance, M. Okay. Now, if I consider okay, let me add some current source here, solid conductor here. Again, let me consider the current source. This is IL. Now, that current source, constant current source. Now, the moment it's constant current source, what about the flux developed? Flux developed also will be constant, and from the center, normally from the center of the conductor, flux will be developed. Flux will be developed. Now, you are going to sit on the same conductor. Okay. Now, the moment conductor current is constant, automatically flux developed magnitude also will be constant. Now, for example, you are sitting at the level of 1, 2, 3. Okay, third flux line. From inside, you are sitting at third flux line. Now, from T10 into minus infinite to plus infinite, you will be sitting at third flux line only. From the center, 1, 2, 3, third flux line. So, you will be sitting at third flux line only. How much voltage you are going to get? Nothing. No voltage. So, for DC, we are not going to induce, we are not going to get any induced voltage because of its own current. Now, let us think of trapezoid. Because I told you, trapezoid waveform is the best waveform to understand networks properly. Okay. Anyway, let me think of this is IL and this is time. As usual, 0 to T1. Current is increasing. T1 to T2, which is constant. T2 to T3, current is reducing. Okay. Now, you are sitting here with this waveform. 0 to T1, my current is increasing from 0. So, whenever current is 0 through the current source, then what is going to happen? No flux lines will be there. Now, my current is increasing. So, from here, one flux line will develop, it will spread. Again, inside one flux line will develop, it will spread like that. Okay. It's a kind of, as it said, if you throw a stone on placid water, okay, in that way waves will be developed. So the moment current is 0, flux is 0, and after that my current is increasing, my flux lines are spreading like this. While spreading, you are going to have induced voltage or not? While spreading, while increasing the current, while increasing the flux lines, you are going to have flux, because this is also, as per Faraday, kind of in any electrical conductor, voltage will be induced if it is influenced by change of magnetic field. So if I'm sitting here, then what is going to happen? The moment you sit here means while spreading, automatically flux linkages will be there. Because of that, some voltage will be induced. On its own conductor between 0 to T1. Again, T1 to T2, flux is constant, current is constant. So you are not going to have any induced voltage at all. Between the T1 to T2, but between 0 to T1, you are going to have induced voltage. Right? Now, if you think of T2 to T3, my current is reducing. So all these flux lines has to diminish and disappear at the center only. What does it mean? These flux lines are reducing and diminishing and disappearing at the center of the conductor. You are sitting here, you will have the interaction of those fluxes or not, yes? So between T2 to T3, you can expect some induced voltage. Okay. Now let me think of, this is VL. What is that VL? It is not because of resistance drop, because resistance is property is different. Okay. People may ask me, sir, this will have resistance also, no? Yes, this will have resistance also because of this variation inductance also, and it is sitting on earth. Right? So ultimately, any conductor should sit on earth only, no? So between conductor separated by insulation, capacitance also will be there. Okay, so the moment current is flowing through electrical conductor, depending upon resistivity of that conductor, depending upon length of conductor or length of current path, area of cross section of current path, resistance will be there. Similarly, inductance also will be there. Similarly, capacitance also will be there, because this conductor, earth is conductor, separated by insulation. So definitely you are going to have capacitance also. But what is our purpose? Our purpose is to understand only inductance. Okay, because for this conductor, you should not assume that, sir, what happened to resistance? Resistance are already, because resistance, capacitance, or inductance, or mutual inductance are sources, are complete properties, are basic elements. We started assuming that they are ideal. While discussion of inductance, we should not think about capacitance. While discussion of inductance, we should not think about resistance, because inductance, it is pure ideal. Okay. Now, coming to the, see here, voltage induced. Okay, voltage induced, VL, okay, is directly proportional to d pi by dt. What is this flux? Its own flux, right? Its own flux. There is no other second conductor which can induce some voltage in this particular conductor. Are directly proportional to, pi is directly proportional, I know. Okay, so in network theory, R VL some proportionality constant. This proportionality constant is inductance. Okay, now we have to add one small point here. That is, see, if I have, this is air core only, or plastic core, PVC core. Okay, PVC. It is not iron core. At all. Now on top of that, let me have some number of turns. 1, 2, 3, 4, 5. Okay, fine. Okay. Now we understood what is mutual inductance and what is self-inductance. Let us combine these two. Problem is solved. Now see here, some current is flowing here, IL. Okay. All this particular current has to flow through this particular turn also, this particular turn also, this particular turn also. It has to flow through all turns, no? All turns, no? Now at this particular position, if I set, it will generate its own flux around that magnetic flux, because current is flowing. Now, means throughout the length of the conductor, it is going to generate. Flux will be generated. And here, flux will be generated for that particular conductor place. For this also flux will be generated. For this also flux will be generated. For this also flux will be generated. Now, if I assume that the distance between turn to turn is very less, such that flux created by one turn is going to link all the turns, which is valid assumption, because okay, for time being it's enough. Okay. Now, flux created by this, if it is linking all turns, flux created by this is linking all turns. Flux created by this is linking all turns. Flux created by this is linking all turns. All turns. Flux created by this is linking all turns. Is the assumption, which is valid assumption in practical conditions also. Okay. Then let us see. See here, flux created by first turn is linking to all turns. Is linking to all turns. So flux created by first turn by its own, right, means my conductor, flux is created, and because of the flux variation, induced voltage will be there in the first turn. Now, if you think of second turn, because of first conductor, because of first turn flux, it is getting induced voltage or not? Yes. Because flux created by first turn is going to link all the turns. So flux created by this is going to create induced voltage here, kind of mutual inductance. If I think of this conductor is different, this conductor is different. Okay, then what is going to happen? Next, because of this conductor, current, flux, in this conductor, induced voltage will be there. Okay, mutual, kind of mutual. Now, because of second conductor, let me consider turns as conductors for time being. Because of second conductor, in first conductor linkages are happening, so induced voltage will be there, kind of mutual. And here, because of second conductor flux, self. Because of second conductor flux, in the third turn, mutual. And here also, because of third conductor flux, first conductor mutual. Because of third conductor flux, second conductor mutual. Because of third conductor flux, third conductor self. So, like this. Mutual, self, mutual, self. Right? Now, altogether, if I have 5 number of turns, how many interactions are going to happen? 25. Or directly we can say, my inductance is directly proportional to number of turns square. Because if number of turns are 5, 25 times more induced voltage will be there. Okay? Then, if I consider, see here, if I increase this inductance by n square times, then for the same current, induced voltage will be more. Because those many interactions are happening. This is about self-inductance. Okay. Now, let me consider, duality. What is duality? We'll separately discuss in duality. Okay. But let me interrelate inductance and capacitance. Okay. Now, let me consider inductance only. What's the big deal? Inductance we are going to show like this because number of turns are having increased effect many times, like manifold, n square times influence will be there in inductance. So inductance symbol is that you know. Okay. Now let me consider voltage across inductance. Passive sign convention already we know. Right? Now my current flowing through this. Let me consider trapezoid. 0 to T1 and T1 to T2 and T2 to T3. This is going to be current flowing through inductance. Okay. Now, let us think of voltage across inductance. The amount voltage across inductance, what is that? Voltage across inductance is going to be L DIL by dt. Are directly proportional to, because L is anyway constant, no? Now, from 0 to T1, my current in this particular inductance is increasing. Meaning that my flux lines are going to be increasing. In increasing order, some voltage has to be induced in that particular inductance. Now, if current is increasing linearly, my slope is going to be constant. dL by dt, IL, T, dL by dt slope. My slope is constant from 0 to T1, right? BL. And 0 to T1, my slope is constant. So it will be like this. From T1 to T2, slope is going to be constant. Or current is going to be constant, or flux is going to be constant. Change of flux linkages will not be there. So ultimately induced voltage will be 0. Up to here it will be 0. And T2 to T3, T2 to T3, my current is reducing, so my flux has to reduce. Okay, so the moment flux is reducing, in reducing order, we should get induced voltage. That induced voltage directly depending upon the slope, meaning that this is going to be okay. Now see here, this particular area and this particular area should be same. Okay, of course directly we can relate this to transients also, but anyway, for example, just let me consider one example and remaining we will see transients. Between 0 to T1 the distance is 5 milliseconds, T1 to T2 10 milliseconds, T2 to T3 again 5 milliseconds. Okay, so T2 to T3 5 milliseconds, 0 to T1 5 milliseconds. In 5 milliseconds my current is increased from 0 to here. In 5 milliseconds only, current is reduced from maximum to 0, meaning that this positive slope equal to this negative slope, meaning that magnitude is going to be same. Here magnitude and here magnitude is going to be same. 5 milliseconds is anyway same, such that area of this and area of this will become same. You understood, right? Now, for example, if I reduce, yes, okay, if I reduce the time, if I increase the slope, for example, if I reduce this to half, okay, so it is going to be T2 to this particular blue is going to be now 2.5 milliseconds only. Previously 5 millisecond. Now I reduce it to 2.5 millisecond. Meaning that, see here, I'll do one thing. This is best. Okay, so between T2 to this particular blue line is going to be 2.5 milliseconds only. So the moment it is 2.5 milliseconds, then what is going to happen? Exactly will become double, such that area, because di is going to be same, no? dt is reduced. See here, di variation of current 0 to T1, my variation of current 0 to, for example, this is 10 amperes, 0 to 10 amperes, and T2 to T3 also 10 amperes only, but time is reduced to half. Rather than 5 milliseconds, now it is going to be 2.5 milliseconds only. The moment it is 2.5 milliseconds, my VL will be shooted. Now, let us think of black, blue, red. Maybe let me consider pink. I hope pink will be visible. Okay. Now, if I still reduce the voltage, if I still reduce the time, again, the moment time is reduced, it has to be shooted. It has to be shooted like this. Okay. Now, if I want to have current change instantaneously, if I try to have current change instantaneously, it should be shooted to infinite. Okay, so my voltage magnitude should be infinite, such that infinite in an instant area, because see here, under this particular red area and this particular red area should be same, or this particular red area, this particular blue area. Yeah, this particular red area and this particular red area should be same, or this particular red area, this particular blue area should be same. The moment time is reduced, it will be shooted. If a time is reduced, it will be shooted. If time is reduced, it will be shooted. If time is instantaneous, my voltage should go to infinite. What does it mean? We can develop surges of voltages by trying to vary our inductance current in a shorter time. That is nothing but our spark plug of our IC engine. Now, let us do the similar kind of analysis for capacitance and then interconnect. Okay. About capacitance, we are able to connect to physical world, right? Because gravitational pull kind of divergence. Now, this is VC, this is IC. Okay. If I consider VC, again same trapezoid waveform. Okay, this is 0 to T1 and this is T2 to this is T3. Okay. Fine. Okay. Now, what is IC? IC is nothing but C dVc by dt. Already we have seen about it. Are directly proportional to. Now, between 0 to T1, my voltage is increasing, kind of dipoles and all we discussed. 0 to T1, my voltage is increasing linearly. So, my distance between the dipoles also will increase. Automatically, current has to flow. So, that current, slope is going to be constant, no? dVc by dt, slope is going to be constant. So, my voltage is going to be constant. Sorry, current is going to be constant. Right? Now, between T1 to T2, what's happening? My voltage is going to be constant. Meaning the dipole, there will be no, variation of the distance of the dipole. Then what is going to happen? You will not get any current. And after that, voltage is reducing across the capacitance. So the moment voltage is reducing, what is going to happen? Voltage is reducing, my dipole distance is going to be reduced. Okay? And don't try to start randomly. Means everything you please start from the first session. Okay? Because continuity will be there. Now, T2 to T3, my voltage is reducing linearly. So slope is going to be constant. Such that again, voltage variation dV, change in voltage is going to be same. If I think of 0 to T1 has taken 5 millisecond, T2 to T3 is also 5 millisecond, then magnitude of this and magnitude of this will become same, because dVc by dt, magnitudes will be same, and also 5 millisecond, 5 is also same. So area of this and area of this, okay, area of this and area of this should be same. Now, for example, if I try to change the voltage in a shorter time, not 5 millisecond now, but maybe 2.5 millisecond. So 0 to T1 I took 5 milliseconds to increase the voltage, but T2 to T3 I am going to take only 2.5 milliseconds to reduce the voltage. Then what is going to happen? See here, voltage variation here and here will be same, 0 to maximum to 0. Okay. Now after that, time is reduced to half, meaning that my IC should be doubled. Now let me consider red. If I try to reduce the time, still means as per that my magnitude should be shortened. Such that this black area equal to black area, this black area equal to blue area, this black area equal to red area. Area of this and area of this will become same, because change in voltages, magnitudes are same. Okay. Now, for example, if you can, of course, physically it's impossible. We are able to derive physically in capacitance, not in inductance, because capacitance in the sense directly we can connect with electric field, divergent field, and our nature, earth, is having gravitational pull, so directly we connect it. But here in capacitor, inductance, we cannot connect. Okay. Now coming to here, what's going to happen here? See, if you try to for example, see here, I have taken 5 milliseconds magnitude. I have taken 2.5 milliseconds, magnitude will be increased. If I take only 1 millisecond, magnitude will be shorted. If I try to change voltage instantaneously in a straight line, such that then what has to happen means my current level should be infinite, magnitude should be infinite multiplied by 1 instant can give you the same area. Okay. So what does it mean? In order to provide, or in order to create, in order to develop or produce surges in current surges, we are going to use capacitance in practice. Voltage surges, we are going to use inductance in practice. So if you want to provide current surges, we are going to use capacitance. And in capacitance, in order to create current surges, you should try reduce varying voltage in a shorter time. Of course, instantaneously it is not possible, right? By varying voltage magnitudes in shorter time. Now, if you want to have voltage surges, you have to make a note of it, buddies. Voltage surges with inductance, it is possible. Inductance, it is possible by varying current in shorter period of time. Current in shorter time. Now, in capacitance, we proved, of course, physically also we proved that how that elastic, some kind of stuff, and such that when it is going to absorb power, when it is going to deliver power. Now, let us become mathematicians because we are in network theory. So, from a mathematician point of view, what is actually power absorbed? Okay, what is power absorbed? From passive sign convention, we know that power absorbed by element. Okay, power absorbed. Obviously, by element we need not write because standard is power absorbed, meaning that power absorbed by element only. Power absorbed equal to voltage multiplied by current entering into positive terminal. Voltage multiplied by current entering into positive terminal is going to be power absorbed. Now, 0 to T1, what is the power absorbed? T2 to T3, let us remove. Okay. Okay, fine. Okay, now 0 to T1, let us consider power absorbed. T2 to T3, let us consider power absorbed. See, power absorbed between 0 to T1. 0 to T1, if you consider, means what is magnitude of voltage, positive or negative? Positive. What is magnitude of current? Positive. So voltage is going to positive only, current is also positive only in the positive direction. Means actually current is flowing into the positive terminal of the voltage. Positive terminal of the voltage is going to be power absorbed. Is going to be positive. Power absorbed is going to be positive because voltage magnitude is positive, current magnitude is also positive. Now, T1 to T2. T1 to T2, what is voltage? Positive. What is current? 0. What is current? 0. So, voltage multiplied by current is going to be T1 to T2. Power absorbed is going to be 0. Power absorbed is going to be 0. Now, try to observe T2 to T3. Now, if you observe T2 to T3, voltage magnitude is positive only, but current magnitude is going to be negative. Already we have seen, right? While increasing the voltage, current will enter into the positive terminal. While reducing the voltage, current will come out of the positive terminal. Means the same thing is happening. In reducing the voltage, current magnitude is going to be negative. Meaning that voltage is like this only, but current direction is reversed. Meaning that between T2 to T3, right? T2 to T3, power absorbed is going to be negative. Meaning that actually it is delivering power. Now, see here, let us consider 0 to 5 millisecond. Okay, 5 millisecond. If you consider, it would be easy to compare. Okay, so whatever may be the, see here, what is power? Power is nothing but voltage multiplied by current. Okay, now into time, if you consider, that is going to be energy. Power into time is nothing but energy. Joules is nothing but watt seconds. Okay, see here, if I multiply instantaneous voltages, if I multiply from 0 to T1 voltage multiplied by current and into time, the same thing will come here also, no? Voltage, because same time, same variation, same magnitude. So 0 to T1 it is going to absorb energy. T2 to T3 it is going to deliver energy. So what is the net amount of energy? Is going to be 0. Energy storage element, no? Right? So the moment it's energy storage element, from 0 to T3, what is the net energy what is the net energy delivered by it or absorbed by it is going to be 0. But you should not connect this with practical capacitor, because practical capacitor obviously some losses will be there, and here we are discussing about ideal. Got my point, right? Now let us see here. In inductance also same thing, and then we are going to connect with duality, and then we will connect with like how practically we are going to develop high voltages in our bikes. Yes, fine. Okay. Now here also, if you see inductance, okay, in inductance 0 to T1, current is positive, voltage is positive, positive multiplied by positive is going to be positive, meaning that my power voltage is here, current is entering into positive terminal of the voltage, so it is absorbing power, absorbing electrical energy into time. Okay, and T1 to T2, current is positive, voltage is 0. So what is the net amount of power absorbed by this is going to be 0. Instantaneous power is going to be 0. Now T2 to T3, current is positive, voltage is negative. Current is positive, voltage is negative, such that what is the net amount of power absorbed is going to be negative, positive multiplied by negative. Meaning that means current will be in this direction only, but voltage polarities will be reversed. This is much useful in case of power electronics. Okay, see here, current direction, continuous, conduction, discontinuous, so many things will be there. If current is going to be in this direction only, but if current is increasing, it is going to absorb power. If current is reducing in the same direction, it is reducing. In the same direction, it is reducing. Voltage polarities will be reversed, and that is going to deliver power back. Now, let us see inductance and capacitance combinedly. I hope you are able to see. Fine. Okay. Now, if I compare inductance and capacitance, wherever in inductance current is there, in capacitance voltage will be there, right? So this is going to be inductance, and this is going to be capacitance. Okay. Now, in inductance, current, capacitance, voltage. In inductance, voltage, capacitance, current. Okay. And if you see formulas also, where is this formula? In capacitors. In capacitance formula is there, inductance formula is there. See here. VL equal to L di by dt, IC equal to C dVc by dt. So, wherever voltage is there, if we can interchange with current, wherever current is there, if we can interchange with voltage, wherever inductance is there, you can interchange with capacitance, wherever inductance is there, you can interchange with capacitance, such that we need not solve two. Actually, if you know only one thing, remaining automatically will be able to solve, because capacitance has to be replaced with inductance, or inductance with capacitance, current with voltage, voltage with current. Getting the point, right? That is duality. That is duality. Okay. Now, how we are going to generate already we know. Okay. Let me think of our bike, our petrol engine, spark plug. Voltages will be in kilovolts. Voltages will be in kilovolts. Okay. Now, if I have maybe battery kind of stuff. Okay. Now, see here. Of course, detail will go in transients. Okay. And let me move a simple way, okay, in this direction. Then what is going to happen? At starting, it will be connected to here. Okay. Let us consider this is 5 volt battery. This is 1 ohm. Okay. Or by to 1 ohm. Let me keep 1 kilo ohm. 1 kilo ohm. Now see here. For DC, see here in this conclusion also I was supposed to have forgot. Okay. So for DC, T1 to T2, current is DC, no? Current is DC, no? For DC current, inductance is behaving like a 0 voltage. What is 0 volt voltage source? Or 0 volts is nothing but short circuit only, no? So how short circuit equivalent of inductance for DC. Equivalent of inductance for DC is going to be short circuit because current is there. Current is there, but voltage is going to be 0. Okay. Similarly here, equivalent of capacitance. See here, T1 to T2. T1 to T2 voltage is there, but current is 0. Voltage is there, but current is 0. So it's going to be open circuit. Open circuit for DC. Equivalent. Right? So for DC application, where my inductance will behave like short circuit and capacitance will behave like open circuit. Forget about it. Come back to here. Now, for example, if the switch is in this particular condition, okay, if the switch is in this particular condition, how much current will go? For DC, once it comes to stable condition, steady state condition, 5 divided by 1K is going to be 5 milliampere. Okay, let me consider this as 1 mega ohm. Okay, so means the moment it is connected here, it is going to behave like short circuit. 5 divided by 1K is going to 5 milliamperes. Current will be flowing in this direction. Now, if I try to change over the switch is being changed over to here. Under that condition, means previous 5 amperes, can it come down to 0 instantaneously? Means in inductance, instantaneous current change is impossible. In capacitance, voltage instantaneous change is impossible. So this 5 milliamperes current before, when the switch was here, 5 milliamperes, the moment switch is moved in that direction, compulsorily 5 milliamperes should flow at that instant. Because current change instantaneously is not possible. Right? So if I try to reduce the current, so reduce the time period for the current change, it is getting shooted, no, voltage is getting shooted. Right? Now, that particular voltage is going to be how much? 5 milliamperes into 1 mega ohm is going to be 5 kV can be generated. Okay, so by having 5 volts, that is 1 kilo ohm resistance and 1 mega ohm resistance and 1 inductance, 5 kilovolts can be generated. So, means huge voltages can be generated with inductance, like surge voltages can be generated by inductance and surge currents can be created by capacitors. Okay. And after that, the kind of duality also we connected. Did we discuss anything? Mutual inductance, self-inductance, link to transformer, inductance, capacitance, duality, high voltage by inductance, high current by capacitor. Yes. With this, session is over. And kindly subscribe to the channel. Use my code if you want to make me more responsible. Thank you guys. Thank you so much.